Here we go, folks. This will be assignment number 29, linear systems of equations with three variables. There will be a lot of overlap between this and assignment 28, so please do assignment 28 first, and then this will build from there. So we have three variables, x, y, and z, and look, the notes are basically identical to what they were with two variables. We could solve this by graphing it very quickly. Graphing would be even more difficult because when you have a three-dimensional coordinate system, x, y, z, this allows you to, this point that's floating out in the air can be described, x, y, z. This is very applicable to the real world because we live in a three-dimensional world, but to graph things that are on a three-dimensional coordinate system is very difficult. So we're not going to go there. But that's the background behind it. And when you take Calculus 3 someday at Princeton, you'll talk a lot about three-dimensional coordinate systems. But the upshot is our solution will be, instead of an ordered pair, it'll be an ordered triple, x, y, z. So I'm going to leave a spot here for our answer, x, y, z, alphabetical. Now, in the process, if we get a false equation like 0 equals 12, that would tell us there's no solution. And if we get a true equation such as 0 equals 0, that would tell us that there are an infinite number of solutions. So those interpretations are the same as they were on assignment number 28. All right, now as to methodology here, there's a ton of ways to do it. But I would suggest to you that since we have the x's lined up and the y's lined up and the z's lined up, that elimination would be the option I would suggest to you. So, another thing I'm going to recommend is that we label the three equations. And so I'm going to label these in what I consider to be a kind of boring way. I'm going to call them A, B, and C. And we'll label them like that from now on. Now, sorry to digress, but I have suggested to former students, and I will to you as well, to be a little creative when you name your equations. Instead of naming them A, B, C, and you can do that if you want, whatever. But I've told people be creative. For example, one time a student, you might not be able to read them, but they labeled the three equations Newton, Einstein, and Sodergren. Wow. Three geniuses, right? Extra points. I don't know, I won't promise you extra points for that. But anyway, have fun with labeling your equations if you choose to do so. Yet another person labeled their three equations, hope I pass. Okay, whatever. I'm going to label them A, B, and C. I'll have more to say about that on example number 2. I bet you can't wait. All right. But anyway, of the methods available to us, I'm going to walk you through, and we could work this problem, if I tried hard enough, 20 different ways. All right? I have time to show you one. My recommendation would be to take the top two equations, which you will notice we have labeled A and B. So I'm going to transfer over the A and the B equations. 3x plus 2y minus 4z. I will tell you I'm being very cautious here because if you make one mistake anywhere in the process, it all blows up. In fact, this is my second time taping this, all right, much to my chagrin. But board space, I learned when I taped this earlier, is a big deal. So I'm trying to be very careful with the board space here. I'm used to having all that board space off the screen to work with, and so I'm trying to be very careful here with that. So, transfer over that first equation, 3x plus 2y minus 4z equals -7. Bring over the middle one, and what I'm going to recommend we do here is we do whatever it takes to eliminate z. Now we could get rid of any of the three, but let's get rid of z. And I think you'll understand why when I'm done doing this, that I picked z, okay? So let's just say for the sake of discussion that somebody said, I want to get rid of z. And again, I'm double checking that I've copied the equations correctly because one mistake and it blows up. All right, if you were going to eliminate z, I hope you would realize the magic number is 12. That's the common multiple for those two numbers. And so why don't we, let's see, it doesn't matter. We need one of them to become positive 12z and the other one to become negative 12z. So let's just say we multiply this top one by 3, right? Negative 12z. So that'll change that one into 9x plus 6y. Remember, we're multiplying every term by 3 here. And then minus 12z. I'm perilously close to the edge of my space here. That's what's making me nervous. And that equals negative 21. I think I'm in there. That blue line there that I put is good. All right, so we distribute everything negative, or 3 on that one. I'm double checking as I do this. I'm not going to make another mistake like I did and spent 16 minutes taping earlier and I messed up. So 9x plus 6y minus 12z equals negative 21. All right, very good. Wouldn't we want to multiply this bottom one? Now keep in mind, that was negative 12z, so don't we want this to become positive 12z? So just like we talked on the previous assignment, we want them to end up with opposite signs. And so I believe we'd want to distribute negative 2 to that equation. Again, apologies for the cramped quarters here. We're doing our best. So that would be 10x minus 14y plus 12z equals negative 76. I'm going to double check my arithmetic again. Positive 10x, negative 14y, positive 12z, negative 76. I think we're good to go. If we combine these two equations, combine like terms, 19x minus 8y, z goes away as planned, and this would be negative 97. Okay, I'm double checking that one more time because one silly arithmetic mistake and the whole thing blows up. So, I believe that is correct. So we took the top two equations and we did whatever it took to get rid of z. All right, now what? I would then suggest we take the bottom two, which again I have labeled as b and c, and we're going to do the same thing. We'll get rid of that same variable, which again I've chosen to get rid of z. Get rid of, eliminate. All right, so look, this is a very mechanical process. My experience has been people do very well with this, except for arithmetic mistakes. And we all make them, and it's frustrating when it happens. I'll be the first to tell you, I taped for 16 minutes earlier on this. I recorded, and I made a mistake, and I had to start all over. Hey, it happens. All right, now, we're going to get rid of z again. And I hope you'd look at the 6 and the 9 and you'd go 18. 6 and 9 both go into 18. We're going to build those up to 18. And so this one would require multiplication by 3. Let's distribute 3 on that one. Once again, I'm making sure that I copy the equations over correctly and that I do the arithmetic correctly. One arithmetic mistake, it all blows up. It's terrible. That's not the end of the world. Negative 15x, positive 21y, negative 18z, and 3 times 38. I'm going to be careful. 3 times 38, I think is 114, but I want to make sure. Indeed, it's 114. Double check your arithmetic as you go. It doesn't do any good to be in a hurry. All right, negative 15x. On this assignment, there will be 4 of these to work. Take your time. Make sure your arithmetic is good. All right, notice that became negative 18z. Therefore, this one needs to become positive 18z. And therefore, that would require multiplication, distribution of the number 2 on that equation. So we distribute 2 on that one, and that becomes 4x plus 6y plus 18z equals 54. One more time, I'm going to double check that arithmetic here on everything. One mistake, it messes up. We heard you. Well, trying to be helpful. Okay, so negative 11x, positive 27y, got rid of z, 168. Check your arithmetic. All right. I always feel like it's useful at this point to just pause for a second, take a deep breath, and do a very quick recap of what's already occurred. So let's recap. Okay, that was a quick recap. What did we do? We took the top two equations and did whatever it took to get rid of z. We then took the bottom two and did whatever it took to get rid of z. Why did we do that? Because these two equations we just created would now be a two-equation, two-variable system of the type we enjoyed on assignment number 28. Look at that. See, that's what you do frequently in math, is you take a new thing, three variables, and if possible, you try to make it something you've done before. Two variables. We now have a two-variable. I'd love to take these off and work them over here. Where did he go? If I had more board space, I'd work these two over here off screen, but I'm going to transfer them up here and look at it. And we're going to go, hey, look! This is now a two-equation, two-variable system of the type that we enjoyed on assignment number 28. We've got this one. Make sure I copy it right. Well, I sure hope I did. I just erased it. And then pull this one up. One miscopy, one error in arithmetic blows up, all right? So be careful. I think that's right. Yes, I'm very nervous. I hope my arithmetic is good. All right. Now you look at this and you say, oh, this is assignment 28. Okay, I should be able to figure out the x and the y on here. Pretending this was an assignment 28 question, I hope you would go, well, that looks conducive to elimination again, so let's pick one of the two variables to get rid of. Should it be x or should it be y? I don't know. Let's flip a coin. Oh man, I'm all tapped out again. I'm really embarrassed here. Anybody got anything? Oh, you over there. Okay, thank you. I'll come and get something to flip here. Oh man, you guys are on fire. All right, we get us another Benjamin here. Heads, Ben, tails, heads, Ben. Heads, X, tails, Y, right? We've already done this. Okay, here's another person that wants to pass the class. Bring me some more, all right? But anyway, and tails. This time we'll get rid of Y. Doesn't matter. That's why I'm saying you can flip a coin if you want. So once again, thank you for that. Oh, look over there, a squirrel. Okay. Hey, Helga. Yeah, it's working. Yeah, they're falling for it. Oh, okay. We're going to get rid of Y. Okay. Now, it's kind of hard when you have big numbers like this to figure out the common multiple. So what I would tell people is if you don't know what else to do, multiply them by each other. All right? So the point would be, if you take 8 times 27, that will indeed be a common multiple. It might not be the least, but we know for sure it'll be a common multiple. So 8 times 27 is, for the record, 216. And so that would be the logic I would suggest you do here. And so the point would be, if you want to get rid of y, you're going to build them both up to 216. And so this top equation, what do you take 8 times? Oh, you take it times 27, right? See, we're going to multiply this one by 27, and we're going to multiply the other one by 8. Multiply them by each other. So if we distribute 27 on that one, 27 times 19 is 513. See, we're distributing 27 on this top equation because we're going to get rid of y, right? 27 times 8, 27 times 8. Multiply the two equations by each other, basically. 513 513x, 27 times 9, yeah, 513x, man, there's some nasty numbers here, minus, hey calculator, what's 27 times 8? The calculator says, you already asked me that, 216. 216y. Get to the edge here. I'm living on the edge. Negative 97 times 27, that's an old song, ask your parents. Negative 2619. I think you can see it. Board space. That's my excuse. All right, so this became negative 216y. Can't we make this one positive 216y by multiplying this one by 8, right? 8 times 27, 8 times 27. Smart. If you don't know what else to do, multiply them by each other. All right? With respect to that particular variable, negative 88x plus 216y. I know that 27 times 8 is 216, right? I already did the math on that one. And then 168 times 8 is 1,344, 1344. Combine like terms, add the x's. Let's see, 513 minus 88. This will be 425x. Y goes away. See, we're just slowly eliminating these variables, getting rid of them. And let's see, negative 2619 plus 1344. I sure hope this is fitting on the screen. I think it is. I'm inside my line. I line them up every time before I do the question. Oh, look! Now we can divide the 425. And it's crazy. And I'll tell you, I was nice to you. I'll just tell you right now, I wouldn't have to have done this, but I believe I made your homework behave similar to these in that these are going to come out nice round numbers. In real life, that wouldn't have to happen. The x, y, z could be crazy decimals. All right, but anyway, x is negative 3. I made a pattern here for our answer. Wouldn't that go right there? That's the value of x. We're starting to fill in the numbers, okay? Now, wouldn't we be able to start finding the others? I would tell a person, once you got it down to 2 equations and 2 variables, you ought to be able to figure out both the x and the y, like we did on assignment 28. So I would hope at this point we go, okay, I'll take that number, stick it in one of these, and get the y. How about this one? So, you come back and you put that negative 3 in there for x, in either one, it ain't gonna matter. And negative 11 times negative 3 plus 27y equals 168. This is just like when we did assignment number 28 earlier, right? So you come and you plug that number. Sorry, I didn't want my line to be in the way. All right, negative times negative, that's positive 33 plus 27y. Have I mentioned that if you make one arithmetic mistake, the whole thing blows up, all right? So, subtract 33. We now have 27y equals 135. I'm nervous about making an arithmetic mistake. Have I mentioned that? And then divide the 27, and it turns out that y, I know I'm all over the place. Have I mentioned I wish I had more board space? 135 divided by 27, I think that's 5, but I'm nervous. Okay. Yeah, it's 5. All right. So y is 5. Ding. See, we're starting to fill in the numbers. There's one more number, z. I hope everybody would realize at this point that we could take the value of x and the value of y that we've discovered thus far and put them in one of these to figure out the value of z, couldn't we? Yeah. Which one? I don't care. Flip a 3-sided object. I don't know. Anybody got something? Oh yeah. Okay. You got something for me? Okay. We'll flip. All right. Okay. All right. Yeah. Hey, thanks. All right. Yeah. Cool. We're going to flip one of these again. Let's say heads, we'll get rid of x. Tails, we'll get rid of y. And if it lands on the edge, we'll get rid of z. No, wait. We're not eliminating. What are we talking about? Oh, we're talking about equations. Head's the top equation, tail's the middle one, and on the edge, how about the third one? Okay, flip it. It landed on the edge. It landed on the edge. That was crazy. It landed on the edge like this. We're going to put it in the third equation, the bottom one, okay, because it landed on the edge. All right? Squirrel! Okay. So, we'll put 5 in for y. We'll put that -3 in for x. Those numbers over there. And so we have 2 times -3 plus 3 times 5 plus 9z, because we don't know z at the present time, and it equals 27. And do arithmetic. All right. These are all numbers that can be crunched out. That'd be -6 plus 15, which is 9. We have 9 plus 9z equals 27. Word space is at a premium. Subtract over the 9, which leads to 9z equals 18. I'm so sorry if this is hard to follow. And then divide the 9, and you would discover that z would equal 2. And you come up here and put 2 there, and you go, wow, that was exhausting. All right, there's your answer, those 3 numbers. So it's a, I don't know, my experience has been people understand the process very well. It's just being careful, being meticulous, taking your time, don't rush through it. You're going to do 4 of these if you choose to do so. I also want to share with you one more math dance. You will notice that as we worked our way across the board there to the right, we eliminated, and then once we started finding numbers, we started to backward substitute them into the previous equations. And a lot of people will call this process, and here's the dance step to go with it, forward elimination, eliminate, 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 forward elimination, with backward substitution. All right? So, you forward eliminate, and once you find numbers, you backward substitute. So one more time, forward elimination with backward substitution. There it is. Whew. I'm exhausted.